We're going to solve an applied problem involving linear speed and angular speed. We have Hungarian Adrian Anis won the gold medal for the hammer throw at the 2004 Olympics in Athens with a winning distance of 83.19 meters. The event consists of swinging a 16-pound weight, which is attached to a wire that's 190 centimeters long, in a circle and then releasing it. Assuming his release is at a 45-degree angle to the ground, the hammer will travel a distance of v0 squared divided by g meters, where g is 9.8 meters per second squared for gravity. V sub 0 is the linear speed of the hammer when released. We want to find the rate, that's revolutions per minute, that he was swinging the hammer upon release. We're going to begin with our equation for the linear distance traveled. We have that the distance traveled s is equal to the initial velocity squared divided by g. G is gravity. We know that the distance traveled is going to be 83.19 meters. That's equal to v sub 0 squared over 9.8 meters per second squared. If we solve this for v sub 0 squared, we'll get v sub 0 squared is equal to 815.262 meters squared per second squared. Now we need to take the square root of that, so we'll get that v sub 0, the velocity, is equal to 28.553 meters per second. The velocity of this linear speed is related to the angular speed through the formula v is equal to r times omega. We know the velocity v. We also know that the radius is 190 centimeters. Our units are in meters, so we want to convert that radius measure to meters. So 190 centimeters is equal to 1.9 meters. We can plug that into our equation. V is going to be 28.553 meters per second. That has to equal 1.9 meters times omega. Solve that for omega, and we'll get that omega is equal to 15.028 radians per second. Now the problem asks us to find out the revolutions per minute, so we need to do some dimensional analysis and change our units for omega. So we'll get omega is equal to 15.028 radians per second times 60 seconds in 1 minute times 1 revolution for every 2 pi radians. If we multiply this out, we'll get that omega is equal to 143.507 revolutions per minute. So for Adrian to throw the hammer the winning distance of 83.19 meters, we need to have an angular speed of 143.507 revolutions per minute.